Welcome to Nexus Tech. Today, we are diving into one of the biggest challenges in all of science, fusion energy. You know, the dream of clean, limitless power? Basically, bottling a star right here on Earth. You've probably heard the old joke, right? Fusion energy is the future, and it always will be. For decades, that's what it felt like. This incredible promise that was always just around the corner, but never quite here.
Well, I'm here to tell you that in 2025, that joke is officially dead. The evidence from this past year, it's just overwhelming. We're talking about a wave of real, verifiable breakthroughs that have completely changed the game. So, let's get into it.
All right, here's how we're going to break it down. We'll look at why this year was such a huge turning point, starting with the insane new power record. Then we'll get into some brilliant new designs that are way smarter and simpler. We'll cover an endurance record that's just mind-blowing and a new national alliance that's pulling everyone together. And all of this, it points to one thing, the dawn of the fusion era.
So what really changed? What made 2025 so different? Well, it's pretty simple, actually. The entire field shifted gears. We went from hearing about long-term promises to seeing real, measurable, honest-to-God technical achievements. The days of just wait and see are over.
Okay, let's kick things off with the big one, raw power. I mean, this is the foundation of everything, right? And over at the National Ignition Facility, you probably know it as NIF, they are not just making progress, they are absolutely smashing records.
Get this. Back in April, NIF hit an energy gain of 4.13. 4.13! To put that in perspective, they zapped a tiny target with about 2 megajoules of laser energy and got over 8.5 megajoules of fusion energy out. That is more than 4 times the energy they put in. Just wow.
And here's the kicker. This wasn't some lucky shot. Look at this trajectory. We go from 1.5x gain a couple of years ago to 2.4x, and now, boom, over 4x. This is a clear upward trend. It shows they're not just getting lucky, they are systematically figuring this stuff out. They're mastering the physics, and they're not stopping there. They've got a roadmap, a clear plan. The goal is to hit somewhere between 5 and 8x gain in the next couple of years, and from there, they're aiming for that magic number. The 20 to 30x gain you need to build a power plant that actually puts energy onto the grid. The path is there.
Okay, so raw power is one thing, but what about making these machines smarter and, well, simpler? That's our next stop. We're going to see how some seriously clever engineering and, you guessed it, AI are totally changing the game.
Check this out. A company called TAE Technologies just announced something huge. They figured out how to run their whole reactor using just one system. Previously, it was this super complex setup. Now, they've managed to cut the complexity and cost basically in half. That is a massive step forward to making this commercially viable.
At the same time, over at MIT, they've built, get this, an AI co-pilot for their fusion reactor. It's brilliant. It uses physics models and machine learning to see plasma disruptions coming before they happen and stops them in their tracks. Think about that. To run a power plant, you need it to be stable 24/7. This AI might be the key to that kind of reliability.
So we've got power, we've got smarter control. But here's the real question. Can these things run long enough to actually generate power for the grid? Well, that brings us to endurance. And yeah, another crazy record just got broken. Over in France, the West Tokamak, it held a stable, super hot plasma for 22 minutes and 17 seconds. 22 minutes. That doesn't just beat the old world record, it absolutely demolishes it by more than 25%. I mean, they kept a miniature star going for almost half an hour. It's unbelievable.
And this isn't just for bragging rights. The West reactor is basically a testbed for ITER, you know, that gigantic international fusion project. So this 22-minute run, it's like a full dress rehearsal. The data they got from this is going to be absolutely invaluable for designing the commercial reactors of the future.
Okay, so you've got these amazing breakthroughs happening in different places. Record power here, smarter designs there, incredible endurance over there. Each one is a big deal. But what happens when you bring them all together? When you coordinate everything with a single unified strategy? Well, then you have something truly unstoppable.
And that is exactly what just happened. This past October, the U.S. Department of Energy dropped a brand new roadmap. And for the very first time, it officially links up all 17 national labs with more than 30 private companies. We're talking about a public-private fusion dream team.
And check this out. One of the key pillars of this whole plan is the convergence of AI and fusion. This isn't just some buzzword they threw in. It is a core part of the strategy. The government is basically saying, hey, that AI stuff MIT is doing, yeah, we need more of that. They know AI is the accelerator we need to get to fusion power and get there fast.
So let's step back for a second. You've got record power. You have smarter, simpler designs. You have marathon-level endurance. And now you have a unified national strategy pulling it all in the same direction. The picture that emerges is, well, it's crystal clear. The momentum here is undeniable.
And this isn't just theory and lab results anymore. This is happening in the real world. We're talking steel and concrete. Commonwealth Fusion Systems, for example, just got the main reactor vessel for their Spark machine delivered. They're on track to fire that thing up for the first time this year.
Then you've got Helion. They just got the final permit to start building their first actual power plant called Orion, and get this, they've already signed a customer. Microsoft is lined up, ready to buy clean power from them by 2028. That's not a research project, that's a business deal.
And don't forget Zap Energy. They just showed their tech can run like a real power plant needs to. They fired off over 100 plasma shots back to back. That's a 20 times increase in how fast they can operate. It proves their system has the kind of industrial-grade repetition rate you'd need.
You know, any one of these things on its own, the NIF record, the MIT AI, the West Endurance Run, would be a big story. But when you see them all happening at once, they stop being individual data points. They become a trend line. And that line is pointing straight up. We've hit the tipping point, folks.
Look, this tech is no longer if, it's happening. So the big takeaway here, what I really want you to think about, is that the conversation needs to change. It's not about can we do this anymore. It's about what are we going to do with it? What does our world look like when we have clean, safe, basically limitless energy? The question isn't if anymore. The question is when.
Honestly, this is just the first chapter in what is going to be one of the biggest stories of our lifetime. To follow the fusion revolution as it unfolds, and to keep up with all the other breakthroughs changing our world, make sure you're subscribed to Nexus Tech. You're not going to want to miss what comes next.